For this video, we're looking at how to find area between two curves. So for this problem, we have two curves. We have the function f, which is linear, and we have the function g, which is a parabola. So what we do know is that the function g is greater than the function f on the interval from a to d. And a is where they intersect here, d is where they intersect here. So g is the more positive function if I'm thinking about positive numbers being up above or to the right, but for this we're looking at positive numbers up here, negative numbers down here. So if I was going to integrate from a to b, I know that both the integral underneath g is positive because I'm going from left to right and the area is above the x-axis, and the integral for f is positive because I'm going from left to right and the area underneath f is above the x-axis. So these are both positive. I know that the area for g is actually greater than the area for f because g is up here, and when you integrate you always go all the way down to the x-axis. So if I showed you the area for g, it would be all of this area right here. So this is bigger. And then the area underneath f would be this area right here, and it's smaller. Well, when we actually do the integration, we're going to do the more positive minus the less positive, and for this interval that makes sense. The more positive would be g subtract the area underneath f. So for this interval we can do g minus f when we're looking at area. For the next interval we're going from b to c. G is still positive, and if I look at the integral for g, it's the area down to the x-axis. So I'm going to say that it's positive area because it's above. Well, my integral for function f is actually negative because it's underneath, so I know that it's minus. Well, if you look at that, I actually want to add in this area here if I'm trying to get the area between the two curves. Well, if I do a positive and then subtract a negative, I'm really adding in this area. So integrating g minus f works for this region as well. The last region is the one that's really kind of the hardest to see. So we're looking from c to d. And if you look at this, the bigger area is actually the integral from f to the x-axis. That's the big one. So I'm going to have that, and this is the big one, so f is bigger, and it's negative. G is the smaller area. It's actually shown here. It's outside of the region we want, but it's also negative. The area for underneath f includes this white space that I have and this little region that's the integral for function g. So when I do f, I'm doing the whole piece, all of this area, and then I'm going to subtract out this piece here. But what I have here is I've been integrating more positive functions, so g minus f. That's what I'm going to integrate. F is the whole thing. It's a negative. So I'm really like adding that in. And remember, g is the little piece I don't want, but that's okay because it's negative. So I'm taking the whole area and pulling out the part I don't want. So more positive minus less positive works on that interval as well. So basically what's going on here is it doesn't matter where your area is, if it's entirely above the x-axis, if it's straddling the x-axis like it is now, or if it's below, completely below the x-axis. If you integrate the more positive function minus the less positive function, you will get the area between the curves, and we're going to actually find this area on the next video.